Hello student, here is a question which says in the circuit shown in figure, the switch was kept in position 1. So this is the position 1 and this switch is kept at this position for a very long time. Okay, for a very long time. This is the circuit. Now at t equal to 0, it is shifted to position 2. Now this connected switch is removed from this position and now it is connected to this direction, the position 2 at t equal to 0. Now we are taking the time as t is 0. The current in the circuit immediately after that is I equal to A upon B ampere, then the value of A plus B is. So we will draw two diagrams here. The first one, that is the position 1, and this is the switch. So this is connected to the position 1 for a very long time and that side is not connected. So this is the diagram for the initial case. Okay, so this is 5 Henry and this is the switch. Now what happens, that this switch is now shifted to the position 2. So we will shift this switch to the position 2. So this is 5 Henry. Okay, so and this one is 40 volt, 40 volt, and that side is 10 ohm resistance, and this is the switch and this is connected to the position 2 and the sorry, and this is 10 Henry. Okay, now this is the condition. So in the first case you will see that the inductance is only L1, which is 5 Henry, but in the second case the both inductors come in contact, come in a series position. So this one is 10 Henry, this one is 5 Henry, both are in series. So the net inductor in the second condition, inductance in the second condition is L1 plus L2 and you will get it as 15 Henry. So the inductor is initially 5 Henry, but in the second case the inductance is 15 Henry, and so the current will also change. In the first case, if we want to calculate the value of current, then we will write it as V upon R, because the inductor is connected for a very long time, so it will just behave like a simple wire without any resistance. So the current is V upon R. The voltage is 40 and the resistance is 10. So the initial current, let us take it as I1 is 4 ampere. So the initial current is 4 ampere. Now when the inductance changes to 15 Henry, the current will also change. So now take the current as I2 and we have to calculate the value of I2 so that we can find A or B. Okay. So what concept we will use? We will use the initial flux is equal to the final flux. Why this magnetic flux is equal? Because initially the inductor is connected for a very long time and the flux is suppose Li. We know the formula for flux as Li. So L1 I1, which will be equal to 5 into 4, 20. Okay, 20 is the initial flux. I1 is flux, initial flux is 20. Now when the switch changes its position from 1 say 2, then immediately the flux doesn't change here. So the initial flux should be equal to the final flux. So phi 2 equals to phi 1 and phi 1 is 20 and phi 2 will be equals to this inductance, which is 15. Li is the formula for flux. So this is the 15 and current we are not known about that value. So 15 I equals to 20. Now I will be equals to 20 upon 15. So it will be 5 into 4 upon 3. So this is the value of A by B. So A can be taken as 4 and B can be taken as 3. So if you want to calculate A plus B, then you can write it as 4 plus 3, which will be equal to 7. So you can write A plus B as 7. Okay. So the answer will be 7. So A plus B is 7. So this is our final answer. I hope that this cleared your doubt. Thank you.